Good morning, everyone. Today we're going to be going over your LED PCB Lab to control a multi-channel LED. This was prepared by myself, Mustafa Fana. I'm an electrical engineering student, and I'm also your embedded tutor for Engineering 11, which is run by Professor Jared Gochico. Today's date, I'm going to just quickly write that in, is September 6th, 2025. But in this lab, what we're going to do is we're going to learn how to use Eagle. That's Autodesk Eagle. It's a PCB design application. It's free for students. And we're going to try to get those PCBs printed and make them into sort of like a keychain for you guys to keep as like a little gift from this course. We're also going to use that PCB later down the line when we do a soldering lab. So this lab isn't completely useless. We're going to be using this PCB that we make here to put in actual components into it and solder them on for a different lab. So let's jump right into this. So the way I set up this lab is that you'll be in a team of 4 and you will design, simulate, and fabricate a custom PCB that controls 3 independent LED groups using a push button. There's also going to be a master switch that activates all the groups of LEDs at the same time. And my goal for this lab was to introduce fundamental electronic concepts and guide students through the full engineering workflow, from circuit theory to simulation, making a schematic design, laying out your PCB, and lastly, in that later lab, physical assembly. So what are some things you're going to need for this lab? For this lab, you don't really need that much, just a laptop. Any laptop pretty much will do. I don't think Eagle is that big of a software. And the other thing that we're going to use is called Tinkercad. It's a free kind of like 3D modeling, circuit design, and kind of like a blender type thing where you could just fabricate 3D objects and stuff like that, but you could also make circuits on it, which is really nice, and I like that. And then lastly, you're going to need Autodesk Eagle, and I already linked you guys a free download version right here. So hopefully Jared will link this document with you guys. And then for people that miss the project, I'm sorry, you're not going to be able to work with 4 students. You're going to be on your own. But this should be pretty easy to follow. It shouldn't be that difficult. So let's go into the components of what we're going to need for this lab. So in this lab, we're going to be working with a 9-volt battery. We're going to work with 4 push buttons, 15 330 ohm resistors, 5 red LEDs, 5 blue LEDs, 5 green LEDs, and 3 diodes. Now, if you don't know what some of these things do not worry about it. This is a beginner course, and you're not going to really get into this until you start doing Physics 4B or circuits or anything else in engineering. You might run into it in some of your later engineering courses if they decide to take the circuit route. I know linear algebra with Professor Quigley, he's doing some circuit stuff, but I don't know the full details about it. But anyway, you don't have to worry about this. Some questions to consider before doing this lab. I don't know why, but I just thought this would be kind of cool that people would know the basics of like what a circuit is, what a PCB is. Just so you know what you're getting into. So, what I said was a circuit is a closed path through which electric current flows. It usually includes components like a power source, which was our 9-volt battery that we were talking about. It has wires to connect the current, so wires are going to be connecting our electrical components. And other devices that use electricity, like lights and motors and other sensors. And then, I kind of looked at this analogy to like see how to describe it in like a beginner friendly way. And it said to think of it as like a racetrack for electrons. If the track is complete, aka the circuit is closed, the cars could zoom around and power through things. But if there's a break in the circuit, or if, I don't know, there's a sinkhole in the track, the race stops and nobody can move. The next question is, what is a PCB? A PCB is a printed circuit board. It's a flat board that holds and connects electronic components using thin pathways of copper. Now, again, you don't really have to worry about this. This is more into like creating the actual PCB, not putting components on it like what we're going to do in this lab. You can think of it like a skeleton and nervous system for electronic devices. It gives structure and it lets electricity flow between parts. So if you have wires everywhere and you, like in a breadboard, and you don't want to deal with all that, the nice thing about PCBs is you could put components into a PCB that allow you to consolidate those wires and make it look nice in a straight line without it being jumbled or tangled or anything. And this is a little cool thing that you may not have known, but you can find PCBs in pretty much everything. They're in your phones, computers, they're in robots, and even in your calculators, which I thought was pretty cool. I didn't know that before this. Going into section 2, again, this is something you don't have to worry about until you get into physics 4B, circuits, all that other stuff before. But I just wanted to go through some electrical fundamentals, such as how a battery works. So a battery is a chemical energy source that generates electrical energy through internal redox reactions. And for everyone that took chemistry, I know you understand what that means. For everyone else, again, don't worry about it. This is the best thing you have to, or the most important part you have to know. So electrons flow from the negative terminal, known as the anode, through the external circuit to the positive terminal, known as the cathode. And you probably heard this analogy before, but the best way to remember this is that cathode, it has the word cat in it, and cats are positive. So if I were to positive, no, that's not funny. Okay, anyway, and it creates a potential difference that drives current. So next we're going to talk about voltage, current, and resistance. So what voltage is an electrical pressure or potential difference, and it's measured in volts. So anytime you deal with a battery, you're dealing with voltage. There's going to be voltage from your battery, and it's going to run through your circuit. Next is the current. The current is the flow rate of electrons. And again, you don't have to worry about what any of that means. Just know it's in a circuit. It's always going to be in a circuit. And it's measured in amps. Next is resistance. And this kind of ties into our resistors that we're going to do. And it's the opposition of current flow. So you can imagine it as like the current is flowing through, and a resistor is not necessarily, but it's pushing against it and not letting as much electrons flow through. And again, that's measured by ohms. And these are all governed by Ohm's law, and Ohm's law states that voltage is equal to current times resistance. And again, you don't have to worry about this. I just added this just for anyone who is interested in it. If you're going to be taking 4B or circuits or anything later on, you're going to learn a lot more about this, so do not worry about this. So let's look at the workflow for this. I decided to put a step-by-step process just so you guys could follow along. If you guys ever get lost in this video, you can go back to this form and just do whatever you need to. Let me see if I can zoom this in a little bit. There you go. So, step-by-step process. The first thing we're going to do is we're going to build this circuit in Tinkercad. So you could follow along this link, and it'll take us to Tinkercad. It's going to ask you to create a profile. Just go ahead and do that with your school email, and then once you get to this page, we could go ahead and click create and create a new circuit. So now we're in our little workspace here. So you can see on the right side you have all your components, and then when you're ready to test your circuit, you could click up here to start simulation, and it'll run everything that you put onto this board. Another cool thing is you could change your wire colors up here, so if you want to be a little organized, you could do it here, but in reality, it doesn't really matter. As long as you understand your circuit, that's really all that matters. So let's start off with our 9-volt battery. You could hold it and click R to reorganize it. I like to keep it organized and everything. And let's grab some LEDs. So remember, we're using 5 red, 5 blue, and 5 green. And the one thing I don't like about Tinkercad is this part right here. You're dragging all your components to the board, and then it gets worse later. So let's go ahead and drag all 15 LEDs. Okay, So now we are going to have to click on each individual one and change their color. And again, this is the tedious part, going through every single one of them and changing them to a specific color. And I wish you could shift click, because it does let you shift click, and it would make sense for it to let you change the colors of every single one of them, but no, it doesn't. So let's go ahead and make these 5 blue. Okay, next, recall that we said we're going to have 15 resistors. So we're going to grab these, and this one you could actually change. So we're going to make them 330 ohms. So right now they're automatically set to K ohms, which is kilo ohms, and we don't want that. We want this one right here without a letter in front of it, just ohms, and we're going to change that to 330. And the one good thing about these resistors, or not resistors, this component, is you could make one into one single variable, and you could hold shift, drag it to select all of it, and you could copy paste them. That's the one thing I like about this. Okay, so now that we have our LEDs and our 15 resistors, remember we're going to be doing this all with push buttons right here. We're going to click push buttons, and we're going to drag 4 of them. Okay, so let's start with the actual circuit. So when looking at our 9-volt battery, we see that we have a positive and a negative terminal. The positive is always going to give you electricity. You could technically count it as like, this is what's going to power stuff. And your negative side is your ground. So this is where you're going to go through your loop and then go all the way back to your negative to close the circuit. So remember, like that racetrack that we were talking about, if you have that loop and it completes back to your battery, that circuit is complete, and the cars could zoom through and go through everything. So with a push button, this is terminal A1, terminal B2. The way that a button works is it's always going to work diagonally. So if you have your red wire, your positive, connected to terminal A1, you have to have your connection at terminal B2. And same for the other wires. If you started at B1, you want to go to A2. So now we're going to drag it into either our anode or cathode. Remember that anode is your positive and cathode is your negative. So we're going to connect to the anode, because we could say that that's like your input of your electricity. You want it to input into this, and we're going to run it through every single LED so that they're connected to each other. So what we're going to do is we're going to take this where it says anode, and we're going to connect it to every single LED's anode. So now all the LEDs are connected, but the cathode also has to go somewhere. It has to get connected back to the battery somehow. So we're going to click on the cathodes of every single LED, and we're going to connect them to each of the cathodes. And we're not done just yet. So we connected them to each cathode, meaning that each negative terminal is connected to each other. But each LED needs a resistor, because a 9-volt battery pushing 9 volts into an LED will cause them to blow up. So we're going to need something that resists electricity a little bit. So we're going to connect our main cathode for LED 1 into our resistor, and we're going to do the same thing we did for our LEDs to the resistors. We're going to connect the bottoms together so that they share a resistance. And finally, to close the circuit back up, we're going to take this terminal 1 for our first resistor, and we're going to put that right back to the battery. So now this is a closed circuit. It's a complete circuit. I know it doesn't look like it because of this section right here, but it's closed because you're going, imagine it kind of like this. So electricity is going this way, this way, this way, goes to this, comes all the way here, goes to each anode, then connects to the cathode, into the resistor, into here, and then sends it straight back to the negative. So we could test that out with the test simulation. If we click that, and we push our button, we can see that it lights up all 5 LEDs. So what we're going to do is we're going to click stop simulation, and we're going to do that for the rest of them. So I'm going to quickly do that, and I will be right back. Okay, so now we're back, and we have all of our LEDs connected the same way we did to the first LED, the red row. So just to recall, just so you remember, just in case my first time wasn't that clear, we always connect our positive terminal to one of the first terminals in our button. And remember, the button works diagonally. So if you choose 1B, you have to connect your other side to 2A. If you choose 1A, you have to connect it to terminal 2B. So next, we're going to take that second terminal that is connected from our button and connect it to each anode. Then we're going to take each anode, like how it says anode right here, click that, and we're going to drag it to each anode. So it's going to be like, you click it right here, it's going to say anode, stop. And then, I don't know why, but you have to click away. Then you have to click anode again, drag it here, stop, click away. Same. Then you connect each cathode the same way. And then you're going to connect this cathode to one of the resistors here down at the bottom. And then you're going to connect each resistor's bottom to each other. And lastly, connect the first terminal back to the battery. So if you have a circuit that looks like this, you could go ahead and test it by clicking Start Simulation. So as we already saw, our first button, of course, works for our red LEDs. Our second button is going to light up our green LEDs. And our third button is going to light up our blue LEDs. And if you're getting a mistake, like, don't worry about it too much. Just go back into the video, see where you messed up. Maybe you had a wrong connection. Maybe you split off a connection, or you're connecting something incorrectly. Just go back and make sure each button is individually lighting up each row, just like this. So now we can click Stop Simulation, and we have our last button to deal with. And remember, in our lab, we want this button to go ahead and light up each of the rows. We want them to light them all simultaneously. So how could we do that? Obviously, if we try to connect our battery to each one of them, it's not going to work. It's going to light up everything, or it's going to mess up our circuit. And that's where that diode comes in. So we can see down here diode, or you could come up here and search up diode. It'll be right up here. So you could drag a diode, and we want that gray line to be facing the right side. So we're going to make 3 diodes, or we're going to copy and paste 3 diodes. So what a diode does is it allows electricity to flow in one direction. So with each of these terminals, we're going to connect to the anode. Again, the anode, remember, takes electricity. So we're going to connect our button there. And since our LEDs are already connected, we don't have to worry about doing anything else with these diodes but connecting them to the anode of each of the first LEDs. Just like this. Oh, it gets a little tricky here because there's so many wires, so it's gonna... There you go. And then our last one connects to this blue one. So since our LEDs are already connected and this button already lights it up, this is pretty much saying, imagine if the electricity taken from here to here travels here and it only allows it to go through this diode, one of these 3 diodes, into that anode. And since our LEDs are already connected, it's going to act like this button right here. And it does that for each one of them, so it sends it through all 3 of them. So we can go ahead and test this really quickly. So if we click Start Simulation, we can go ahead and click it, and we can see all of our LEDs are lighting up. And that's exactly what we want. So now we're done with the Tinkercad simulation. We got a basic idea of how we want to build our circuit, and we're going to transform that and translate it into Autodesk Eagle. So we click Stop Simulation. I want everyone to go ahead and take a picture of this and save it for yourself later, just so we could understand Eagle a little bit easier. And then one thing I do like about Tinkercad is if you see on this top right, there's a few buttons up here next to your profile. And specifically, we want to look at this second one. This is schematic view. So in Eagle, everything is built in schematics and boards. So if we click on this schematic view, this is how it would look like in Autodesk Eagle. Not exactly, because of course this is Tinkercad and everyone can make it in their own ways, but this is how a schematic will look like. So it'll genuinely look like this. Okay, so next we're gonna load up Autodesk Eagle. So when you download Autodesk Eagle, it'll tell you to create an account, and just go ahead and do that, and it'll bring you to this page here. Now remember, I said we're gonna have some libraries down on our dock. It says that we're gonna have some libraries that we're gonna plug in. I believe it's at the bottom. Yeah, right here. So these are the 3 libraries that you'll need, and I'm gonna link these all. I hope I could give them to Jared, and Jared could find a way to put them in like a Google Drive to give you guys to access. But yeah, these are the 3 libraries you're going to need, and basically this is a library that has pretty much every component. It just makes it easier to find, like buttons, resistors, LEDs, stuff like that. This specifically, the 1825910-6, is a library that has that specific button we're looking for. And Eagle is weird, and when it comes to finding components and purchasing components, the way that I was able to find this one is going to a website called DigiKey. It's where people upload schematics that you could also purchase. So if you were to use a component in Eagle, for example, let's say we go back to our Tinkercad, and we have an LED, and it has a specific diameter, it has a specific sizing. If you were to go to DigiKey and download a footprint or the library, it would be the exact shape and size that you would need in Eagle, and you could easily purchase it and it'll fit your PCB board. But anyway, back to Eagle. So next we're going to click on libraries, and there's going to be something called libraries right here that we're going to click down. And again, like I said before, these libraries are your different type of footprints or components that you're going to be adding externally. Eagle has their own library, but there's always external ones that you could add in to have more stuff. So once you download the files that I give to Jared, you're going to find them in your Documents tab or in your folders on your computer. And when you access it, it's going to look like this, kind of like how you see on mine, where it shows like little books. There is a page that tells you how to import them, but the easy way to do it is just dragging and dropping it into specifically the libraries portion. Now for me, it doesn't let me do it because I already have it, but once you do put it in, it's going to look like this, where it's grayed out, and that pretty much means that your library isn't in use. So what you want to do is you want to click that gray button until it's green. So that tells you that you do have that library in your Eagle now, and you're able to use it. So next, we're going to find our way down here to projects. We're going to open it up, and I have some projects already, but imagine it had nothing in there, and we're just on the projects tab. We're going to come down here to create new project, and for the sake of this, we're just going to call it Pcb Lab. So again, like the libraries, if it's not green, it means that it's not in use. So we're going to click on this empty project. We're going to right click on it, hover over new, and we're going to create a new schematic. So now we're in Eagle. This is where you're going to have all your work tools. If you used SolidWorks or anything like that, it's kind of the same way, kind of not. But it's easy to navigate. So we're going to hover to our left and see a whole bunch of things. Right here is the most important part where it says add part. We're going to click on that, and it's going to bring us this huge drop down of confusing names. None of these look familiar. Maybe some of them, like resistor power, but a lot of it is code named, I guess you could say. So remember, we had one called the 1825910-6. That's our button. So let's start with the things we know. So we had 4 buttons, and the way that we do batteries in Eagle is weird. So it's not like a battery that you could place. It's like this right here. It looks like it says battery, right? But it's not really a battery. It's like a shell of a battery, but it's not easy to do. It's pretty hard to connect a battery like that. So what we're going to do is we're going to come to this thing right here. It's called Con Phoenix. And what these are connectors. Like these. You see how there's 1, 2, 3 ports? We're going to create our own connectors. So one of them is going to be for the positive 9 volts of our battery, and the other is going to be our ground. So kind of like how we had in this Tinker Lab simulation. One hole is going to be for the positive, one hole is going to be for the negative. So we have our battery, and we have our 4 buttons. The next thing we're going to need is our 15 LEDs. So let's hop back into Eagle. Let's go to Adafruit now. Remember, that gives you all these other things, and it tells you, like, look at this. We have diodes already, and if you go a little bit further down, we have LEDs right here. So reading the description helps a lot. So we're going to click on this 5mm LED, and we're going to flip it so that it's facing downwards. And then let's go ahead and place 5 here. And the one good thing about Eagle is you don't have to worry about changing the colors. You could do that on your own. So let's go ahead and place 15 of them. And then remember, oh, I accidentally clicked out of it. So if you accidentally click out of it, again, just navigate to add part, and you'll be right back to where you were. So next, we're going to scroll all the way down until we hit R. If not, you could also just click on a random place, click R, and it'll take you straight to the first letter in R. And this is exactly what we're looking for, RCL. We're looking for, or RCI, I guess. It stands for resistors, capacitors, and inductors. So we're going to click onto it, and we're going to look for resistors US, R-US. We're going to click on it, and it tells you popularity. This is the one thing I like about Eagle, because if you're not sure what exact part, because these two look the exact same, the one thing that's different is the grid millimeter size. So seeing what people use for popularity is honestly one of the most useful things. So again, just like we made in our Tinkercad simulation, we're going to place our resistors the same way that we did before. Perfect. Next, we needed our diode. So let's go back into Adafruit, which is all the way at the top, or just clicking A. Hover over D, and we're going to use this diode. Where is it? We're going to use this one right here. Are we? No, we're going to use this one right here. The AN4004. So it should be one of the first things that pops up in Adafruit. I don't know why they separate it like that. But yes, we're going to be using this one right here. So we could flip it. We could have it the same way we had it before, where we have 1, 2, 3. We could drag around our parts by looking for these little pluses in our components. Other than that, it will not let you move your component. It'll bug out. So just look for the little pluses. And an LED, I think it's just the complete center. But other than that, you can drag and do everything like that. Way easier than Tinkercad. So let's start organizing a little bit. We want to separate these so that there's not too much going on. Okay. So now that we're here, let's start with what a net is. A net is technically like your electrical copper wiring that connects everything. So kind of like how we were drawing wires in Tinkercad, using this net will allow us to draw connections in Eagle. So for example, let's say we're following that battery diagram and we see this top one is our positive and this bottom one is our negative. So we could draw a little line right here. It'll format it like this so you don't have to worry about it being straight or not. And we're going to stop it right there. We're going to click exit to get rid of it so we can start a new net and we could make it the same size. Next, we're going to go to this name value right here, right under the junction dot. And we're going to click on the line and we're going to name it 9 volts. So this indicates that our name for this line is called 9 volts. So anything that connects to this line will be connected to 9 volts. So, same we could do here. We're just going to call this GND for ground. And that's kind of like anything that's connected to this is connected to the negative side of the battery. So, we're going to grab our net again, and we're going to continue from our 9 volt path, and we're just going to drag it to, again, any of the first 2 components, and then we're going to do it diagonally for the other side. So let's say we choose 2 for here. So now we're going to take 3 and we're going to connect it to the LEDs. And for this, it's I know it doesn't tell you anode or cathode, but you could easily just search up schematic LED symbol and it'll tell you which side is positive. But I could tell you right now that the one with the triangle's bottom is positive. So we're going to take all that and we're going to connect each one. One thing that I like about Eagle is you don't have to click on each one individually. If you just go all the way to the back, it'll connect all of them. So next, we're going to take, like we did in our Tinkercad, connect 1 here. And then we're going to connect to that one. That one is going to then connect to all of these. And then lastly, our resistor is going to connect all the way back to our battery. So that's going to say, do you want to merge N, whatever name you gave it, into ground? Just click yes, and now it's connected. This circuit is now working. And you could, again, follow the same way that you did to the other one. So I'm going to stop the video here really quickly, do that, and I'll come back, and then we'll set up the master button, and then we're going to go to our board view, and we're going to assemble it and do everything there. So I will be right back. Okay, so now we're back, and we have everything wired up the same way. And if you're a little confused, don't worry about it. There is a picture in your packet that I do have my Eagle set up, so you can just go ahead and follow along with it. And just for clarification, these little dots right here that you see, they're called junctions. So that's just right under the net. So if you're not understanding this at all, just go ahead and place junctions everywhere that I put, and just follow along and you should be perfectly fine. And I did look over the recording and I realized that at some point it gets really, really choppy. So I'm sorry about that. From now I'll try to be like this, really close, just so you get the main picture, even if it starts getting blurry again. So we went ahead and we connected everything the same way that we did the first one. So we have power going into one side of the button, into the diagonal side, into each LED connected together. One of the cathode or anodes of the LED connects to the resistor, where all the resistors are connected, and they go back into ground. So next we're going to talk about this right here, the master button. It works pretty much the same way. So you could click your net, click anywhere on your 9 volt battery, and do the exact same thing where we connected to 1, connect it to the diagonal. So we're going to take this right here and we're going to connect it there, there, and there. Oh, actually that's wrong. We don't want a junction there. So what we're going to do is we're going to do this. We're going to create one right here, and we're going to connect everything to this point right there. Just like that. So now all of them get connected via one point and not get confused from here. So next, we're going to take the first ends of each of our diodes, and we're going to do the same thing we did in Eagle, or the same thing we did in Tinkercad, my bad. We're going to connect it to this line right here. And actually, no, we're not. We're going to have to go here, and we're going to have to drag it to, we're just going to go a little bit above, go right here, and connect it into the first LED. And we're going to do the same things for the other ones. We're going to drag here, stop right there, go right above the first LED, and connect to the anode, or the cathode, I'm sorry. I get those mixed up a while. Last one with the third one, we're going to come right here, click right there, go right above the cathode, and connect it. So now our button is completely connected. So now this should work exactly like our Tinkercad model. So the next thing we're going to do is we're going to go over to the top left where it says File, Draw, Edit, Everything, and you're going to see this button right here, this green button that says Generate and Switch to Board. Just go ahead and click that. It'll tell you, do you want to create a board for this project? And just click yes. This is our actual PCB designing board. So if you were to go ahead and click manufacture, you can see this little green part is your actual PCB. And we have all of our components right here as well. So we have our 2 holes, that's going to be our power. We have all 15 of our LEDs. And we have our resistors and our buttons. So let's go ahead and drag our power first, and we could organize it however we want, and let's put it right here in this corner. Next, what we're going to do is, and this is another good thing to do, go ahead and click on the name tab and name each one of these LEDs. It'll just make it so much easier. So I'm just going to quickly go ahead and do that. So I'm going to go through each of them, name it red 1, red 2, red 3, red 4, red 5. And also name your button too. So just name it like red button. We're going to do the same thing with the green. We're going to call it green 1. And if you don't want to go ahead and type all this out, just type G1, G2, R1, R2. But just to make it look a little bit nicer, we're going to do and to make it easier in the board view. Because if you probably saw in the board view, it just said LEDs for all of them, and they had a whole bunch of wiring everywhere, and that's kind of confusing unless you know exactly what you're looking for. So I'm just going to save time and call this G button. We're going to name this, just for the sake of time, actually blue is pretty easy, so we could just call these blue. Blue 2, blue 3, blue 4, and blue 5. And then lastly, again, we're just going to call this B button. And then just so you're not confused, just name this one master button. Okay. So now if we go back into our board, you see everything is labeled now. That makes it so much easier to find all your components. So now you could find where red 1 is, and that's right here. And we could just start putting them on now. So we go red 1, red 2, we'll just keep going 3, and you could arrange this any way you want. So don't let this video stop you in making your own creative path. And again, we can see this line connects to R1, so we could just put the resistor right under it. R1 connects to R2, which then connects to R3. That's connected to R4. you could kind of follow how this one is going to go. So if you want to follow the path, so it seems like the way that we assorted it right now, this right side is ground. And you can kind of see, if you zoom in all the way, you can see 9 volt and ground. So let's go ahead and reorganize based on that. I guess it would be easier if you also name the resistors, because it looks like it's not in complete order. Looks like this one's in order, but the rest of them, oh no, they seem to follow suit. Okay, I am just tripping. But anyway, you're gonna fix the mistake that I made. I did not do this as optimal as I should have. But you could drag everything. You could take your red button, place it there. We're gonna take our green button, place it right there. Take our blue button, place it right there. And take our master button and place it right there. Just make sure everything fits onto the board. We'll just quickly assort them, and then on your own you could organize it and fix it as much as possible. Rename things if you want to, and just make it easier on yourself. So let's see. We have the green ones right here. We have green 1, green 2, green 3, green 4. There you go, green 5. And of course we have all the resistors that come up to it. So this is going to take a little while, so I'm going to come back when I have everything fully on the board and organized and everything. Okay, we're back now, and we have everything on the board. And the way that you could change your board size is taking this little thing and dragging it along and just changing the size. So I do want to make this into a little keychain for you guys, so you could use it before we do the soldering lab. So what you could do is you could go to this right here, your layer. You want to go to your dimension, and you want to click on this circle tab right here. What that's going to do is it's going to create a circle, and you could just click it, make it any size you want, and it'll cut a hole based on however big you made it. So for me, I decided to just do this little corner right here, and if we go into our manufacturing view, it looks like this on our board. You can easily make that into a little keychain. And then I also want to add this here. So I want you guys to put what team number you guys are on, and the names of everyone in the team that you're in. Solely because when we order these, they're gonna come in bundles of 5. So obviously every single one of you guys are gonna have your own PCB board to have. And then just so you know who is in your team, you're gonna have the same team in your soldering lab. So I want you guys to have your team name, and we're gonna quickly learn how to do that. So we're gonna go right here into layer 21 where it says not 21. I'm so sorry. We're gonna go right here into T names. Next, we're gonna click. Where is it? It's a text box right here. This A right here, text. We're gonna enter a text. For example, I'll type whatever. Team 1. I'll say is me, Jared, and our other embedded tutor, Isaac. Next, we're just going to drag it anywhere we want. Let's say I want to put it right above there, and boom, it's there now. And if we click on our manufacturing again, it'll show that it'll come up. So when you send this to a PCB billing place, it'll have this inscribed into the board for you, which I think is really nice. So it'll look really nice. Next thing we're going to learn is how to export this file. So if you go to right here, manufacturing, you can see that it says a few things right here. So the one thing you want to do is you want to click this launch cam. And it says the design has changed. Oh wait, I have to get rid of the name, my bad. Let me do that really quickly. I want to get rid of this one. There you go. Launch cam. It's going to say your design has changed. Do you want to save the design? Yes. It'll give you all of this stuff. I don't think you have to worry about it. Just go to no, I think everything should be good. This is just a way that you could check all your files. So it'll show you your top board, your bottom, or your top layer, your bottom layer, the profile, aka the hole we just made, and then every single soldering mask that comes by. And then what we could do is we could just click process job. It'll tell you to save it somewhere. I guess you just select that folder. It's going to tell you to... It's just say that it was complete. Perfect. So now we're going to open the folder. And now we have this B1 file. And we have our cam outputs. So this is everything that we need to give into the PCB manufacturing website, and we'll order them for you. So if you got to this step, you're perfectly fine. Everything is good, and everything is sunshine and rainbows. So I feel like if you get to this part, you're happy with your board. You have successfully completed this lab. And one other thing, actually, I forgot to mention that was very important, so I apologize. If you go back into your, where is it? No, right here. Stay in your board. You go into tools, and you could do this ERC check. This ERC is going to give you everything that's wrong with your circuit. So you can see there's a lot of errors, but that's because it says that they're unconnected, and that's solely because we already connected them at the bottom. So a lot of these, they could be warnings, but some of them are just saying like, oh, the blue doesn't have a value because you can't really give it a numerical value. Green doesn't have a value. Red doesn't have a value. PX1 doesn't have a value, but it's just 9 volts, we're going to call it. The other one doesn't have a value. And it's going to say the same thing, like unrecognized port. The ports aren't connected. But we did connect them at the other side, so there's no reason to worry about that. So once we are done with that, we can hit tools again, go back into our board, hit tools again, do a DRC, which will tell you everything else that is wrong. Air wire, of course, is just telling you that there's wires going into the component, but you shouldn't really worry about that because it's just going to look like little lines that go through, like when we do this next tool right here. One more check, you can just check errors again. It'll tell you any errors that show up, but again, most of them you don't have to worry about. Next, if you go to auto router, it'll route all these wires for you and give you actual connectors for them. So we can put that into high, auto, and we're going to click continue. And then we're going to click start, and you're going to see that it's going to run a whole bunch of wiring through everything till it finishes. Once it's complete, you can just select which one you want. It doesn't really matter which one. Usually the top one is the most, I guess, the best, the one that Eagle finds the best for it. You can just click evaluate. Now your board has electrical copper wiring through everything. Now if you look into your PCB, now it has little wires that go through it. So it tells you how things are connected on the board. So again, my bad. Before you export everything, do those 3 settings. And then after you do that, auto route it, and then just make sure everything is correct. Make sure you have these blue and red wires. After that, manufacturing, cam, make any save changes, process the job, and save it into your directory. If it's replaced, yes, you want to replace it, and there you go. Now you have your cam outputs, and everything should be perfect. And that is the official end of this lab. Thank you so much, and I hope you enjoy it, and I'm so sorry this video was so long.